in section 11.2. So example 3 looks more complicated because it has these fractions. And I show you the strategy on how to solve these fractions last semester. So we need to identify the A, the B, and the C, right? But before we do that, we don't want to have these fractions. So the best thing to do is to multiply by the highest denominator, the whole equation. I'm going to put it in a different color. So we're going to multiply by 4. Why am I doing that? To cancel all these fractions. So the first one would be 4 times 1 would be 4 over 4 m squared. 4 times 1 would be 4m. Plus 4 times 1 would be 4 over 2, and 4 times 0 is a 0. So if you notice 4 over 4 becomes a 1. So you get m squared minus 4m, and 4 over 2 is 2, and then this is 0. So this is allowed in mathematics because we are keeping the balance of the equation by multiplying both sides by this number. So we're not changing anything. It's still the same equation, it just looks different. Okay, so those are the things that you guys need to get good at math. Math can be manipulated in this manner, in different ways. There's different techniques. Okay, so now we do the A, the B, and the C. So the A would be 1, this one, and then the B would be -4, and then the C would be 2. So now we're going to use the same formula, -b plus minus b squared minus 4ac over 2a. So let's put it here. So again, we got a double negative here, negative and -4, plus minus -4 in parentheses square minus 4, the A is times 1 and the C is times 2. So let's go this way. So negative becomes a +4. You don't have to put the positive, just put it there so that you see. 4 times 4, 4 squared is 16 minus 4 times 1, 4 times 2, 8. Over, forgot the over. 2 times a, which is 1. So 2 times 1 would be 2 here on this side. I forgot this part. So that would be 4 plus minus 60 minus a would be 8 over 2. So again, whenever you have a radical, make sure you simplify it all the way. So this can be changed into 4 times 2, and this is the 2. So 4 plus minus square root of 4 would be 2, square root of 2 over 2. So I can just get a 2 from here and from here. So this would just give me 2 plus this cancels out, so square root of 2 over, and don't forget we have the 2 outside, the GCF over 2. So again, this goes away, so you have 2, and I forgot the plus minus on this side, so plus minus square root of 2. And you can express it like this, like that. That's the answer, or this one. So fast the bell already rang. So I'm gonna skip example 4. You guys should be able to do it. This is gonna be an imaginary, so you will have to remember these things. So you have to remember that for this one. I'm still gonna do it in classes. So let's do example 5. Example 5 talks about the discriminant, which is this part of the quadratic formula. So if you guys remember the quadratic formula, so this part here would be the discriminant. So this part of the quadratic formula tells you how many solutions we're going to have or what type of solution we have. So, for example, if you get a positive number when you substitute the A, B, and C, there's two real solutions. If you get a 0, when you substitute those numbers here, you get a 0, that means one real solution. If you get a negative solution, that means it's going to be a complex, but not a real solution, so an imaginary one. Graphically, this is how it looks. The positive two real solutions, you have these two dots where they intersect the x-axis. Those are the solutions that we've been working with. Solutions is always when the dots of the graph that intersects with the x-axis. So positive discriminant is going to give you two solutions, those two dots. Zero discriminant, 0 again, one real solution, is because it's intersecting with the x-axis once. So that's why you have one solution, one real solution. When you get a negative number, you have a graph like this where it doesn't touch the x-axis. So negative discriminant means it's not touching the x-axis, and it's going to have two complex solutions but not real solutions. So two imaginary solutions. Let me show you how that works. So again, we get this, and I'm going to show you that one too. There's two examples I'm going to try. So let's identify the A. The A would be 1, the B is 2, and the C is 1. Now using the discriminant, which is this part of the quadratic equation, is B squared. So the discriminant, it's B squared minus 4AC. So based on that table that I just show you, the positive, 0, and negative, we're going to use the discriminant to determine the number and type of solutions of each quadratic equation. So let's substitute. So B squared would be 2 squared minus 4 times A, which is 1, times C, which is 1 again. So this 2 squared is 4. 4 times 1 times 1 gives me 4. So again, I'm using this one. It gives me 0. So I get a discriminant of 0. That's our discriminant. So what does that mean? When we get a 0, we have one real solution. We get one solution, so that's the number of solutions, and it's real. The type would be one real solution. So if you show me this, that would be good. So with the 0, so one real solution. Very easy. Now this one, identify the A, the B, and the C. The A would be 3. The B, there's no B. If you notice, there's no X by itself. Without the exponent, I mean. So 0. And then the C would be the number by itself, like this one, so 2. Now let's substitute into this one again. So B squared, so 0 squared minus 4 times 3 times 2. So 0 would be 0, 4 times 3, 12, 12 times 2, 24. So we get a negative 24. So we get a negative. So here we got a positive discriminant, right? Actually, no, we got a 0. Sorry. 0, so that means one real solution. When we get a negative, so we can look back to the table. Negative means two complex but not real solutions. So that's why you got two complex but not real solutions. And I'm guessing this has to be the other one. So A would be 2, B is negative 7, and C is negative 4. So again, let's use this one. B squared minus 4AC. So B squared negative 7 squared minus 4 times 2 times negative 4. So 7 times 7 is 49, minus becomes a positive, so this is actually going to be a positive. 4 times 2, 8, 8 times 4, 32. And that gives us 80. So that's 70, 81. So this is positive discriminant. So this was a negative discriminant. This is a positive discriminant. So that means it's going to have what? Let's flip. Two real solutions. So it's going to have two real solutions. So, and this is how they look graphically. So the first one would be this one. This one is one real, touching the x-axis once. The second one would be this one, where it doesn't touch the x-axis, so no real solutions, two complex ones. And the last one would be positive, which is two real solutions touching the x-axis twice. And that's it, guys, for the notes.